Here in this video we are going to see a problem on DLS, that is development of lateral surface of a cone. For that, here we have a question. A cone of base diameter 70 mm and axis 90 mm long is resting on its base on HP. It is cut by a section plane perpendicular to VP and parallel to and 15 mm away from one of its end generators. Draw sectional top view, front view and DLS of the truncated cone. So this is the question in front of us. By reading it, we understood that the type of solid is a cone, and since it is kept on HP, it means it is kept on the ground, and from the top we are going to see the circular base. So that will be drawn in HP, and the front view of the cone will appear as a triangle. It will be in VP. So at first I am going to draw the initial condition of the cone and then locate the cutting plane, and finally we are going to go for the sectional top view and DLS. Let us get started. The base diameter of the cone is given in the problem as 70 mm. So I'll take the radius as 35 mm. Drawing a light circle through this center, taking radius 35. Now this is the circular base of the cone which is visible from top. I'll divide it into 8 equal parts, measuring 45 degrees on both sides. Now here I have divided the circular base into 8 equal parts and giving it the notations. Next, here is the apex point O, which appears as a point from the top view. Now I have to draw the front view for this cone, which is a triangle. The height of the cone is 90 mm given. So I'll measure 90 here. So these are the generators of the cone. Here is O dash, apex. This is point 1 dash, 2, 3, 4 and 5. Where we have 4 at the same location we have 6, 3 and 7 are coinciding, and 2 and 8. Now this is the initial condition of the cone. After that, here I will be locating the cutting plane. For that, the condition is given in the problem. It is cut by a section plane, which is the cutting plane, perpendicular to VP and parallel to and 15 mm away from one of its end generators. So here they have not given the inclination of the cutting plane, but they have said that the cutting plane is parallel to and 15 mm away from one of its end generators. So I have to take one of the end generators as the reference. Here if I take O dash 5 dash as the reference, so cutting plane will be parallel to this end generator and 15 mm away from it. So I have to draw a line parallel to this slant edge or the end generator, and it should be 15 mm away. So for that, here I am explaining the procedure how to move about it. First, from any of the points of this generator, like for example anywhere in between, or either if we can say that anywhere in between, I am selecting a point, arbitrary point on this end generator. From that I am going to measure an angle of 90 degree. Here I am measuring 90, drawing a light line through it. Then I will be measuring 15 mm on this perpendicular line. So taking 15 mm over this line. Now this is the point through which I should draw a parallel line to the generator O dash 5 dash, which I am taking as the reference. Even if you are taking the reference as the other generator O dash 1 dash, then also you are correct. So here from this point I'll draw a parallel line to the generator. Now this parallel line indicates the cutting plane, so I have to make this cutting plane dark. So here I have located the cutting plane, calling it as cutting plane AA dash. Now when we are looking from top as an observer, the part which is close to the observer should be removed so that we can see the section. It means whatever portion is there at the top closer to the observer, this will be removed and the bottom portion will be retained. So the part which is retained, I'll make it dark first. So this much bottom portion of the cone has been retained, and here the cone has been cut. So a cut cone is also called as the truncated cone. So this is the truncated cone, and here we have to draw the sectional top view as well. So for that I will be giving the notations where the cutting plane is cutting the generators of the cone. Now where it is cutting O dash 1 dash, I'll say that point is A dash. So first I'll project this A dash downwards. A dash is on O dash 1 dash, so in the top view it will be on O to 1. So projecting it vertically downwards. So A dash has been projected in the top view. This will give me point A. Then cutting plane is cutting the generators O dash 2 dash and O dash 8 dash at the same location. So it is cutting at this point. Where it is cutting O dash 2 dash, I'll say that point is B dash. And where it is cutting O dash 8 dash, that also I'll give the notation. But since it is cutting O dash 2 dash first, I am plotting it light, projecting it light up to generator O to 2. So here this is giving me point B. Then at this same location we are having O dash 8 dash. So where the cutting plane is cutting O dash 8 dash, I'll say that point is H dash. So it will be on this same line, and now it should be on O to 8, that is point H. Then here it is cutting 3 and 7 exactly at the center, so this point should not be projected directly downwards. It should first be transferred to the slant edge. Any one of the slant edge will do, and then I have to bring it down. So where it is cutting O dash 3 dash, I'll call that point as C dash, and projecting this C dash onto the slant edge, projected onto the slant edge. Then I'll bring it down. This is the method which we should use when any of the generators is being cut at the center. Now I have taken this point, so measuring the radius from point O up to this point, which I have plotted it in the top view, and it is cutting O dash 3 dash at point C. So here it should cut O to 3, and this will represent point C. Similarly, where it is cutting O dash 7 dash, I'll say that point is G dash. So G dash will also be at the same distance, but it will be on generator O to 7. So the same radius which I have taken previously of O to C, plotting it on O to 7. This will give me point G. Then the cutting plane after that is cutting directly the base. See, in case of cone, whenever the cutting plane is passing through the base, then we are going to get a straight line. So that straight line, I am projecting it in the top view. It is this straight line. It means here it is cutting at two locations. The base has been cut at two locations. So I'll be giving the notations. I'll say this point is D, and this is point E. So these are the points which we are getting when the cone is cut as per the given conditions. Now I'll have to join all these points in the proper sequence, and for joining them we have to draw a curve, because since it is a cone, and here I am going to draw that curve with the help of light line first. After drawing it light, I'll make it dark. So this is the curve which we are getting. Now here, as I have explained, when the cutting plane is passing through the base of the cone, in that case we are going to get a straight line. So from E to D it should be a straight line, straight vertical line. Then the right hand side portion, that is from 4 dash to 5 dash, this part has been removed. It is light, it has been removed. So whatever is there behind, that is retained. So I'll make the retained portion dark. Then after drawing this retained portion, the portion in which the cutting plane has cut the cone, in that we have to draw the section lines inclined at 45 degree. So here I would be drawing those section lines. So here is the sectional top view. Now after this we have to draw even the development of lateral surface for this cone which has been cut, and for that here I am explaining the procedure. First we have to draw a light line from the apex, then parallel to the end generator O dash 5 dash a line will be drawn. Now here I'll say there is this apex O double dash. So next I'll have to measure the distance from O double dash to this slant edge, and then drawing a light arc. Drawing a light arc. Now I'm using a method which is more fast. For that I have to take the distance from any division, that is I'm taking the distance from 1 to 2, and as we have divided the circle into 8 parts, we have to divide this arc also in 8 parts. So that procedure I'm explaining. I have taken the distance from any one of the division from 1 to 2 and dividing it into 8 equal parts. So I've divided it into 8 equal parts. Next, joining all the divisions at the apex. Now, divided this into 8 equal parts. So giving the notations, and here we are going to open this cone for the development from point 1. So I am opening it from 1. So starting with 1 double dash, 2 double dash, and in order. Now after this, as I have plotted the points, starting with A dash first, that should be plotted onto the development. So A dash will be projected light. Here we have A dash on, it is on O dash 1 dash, so here it will be on O double dash 1 double dash. This is A double dash. Then measuring this same radius from O double dash to A double dash, and plotting it on O double dash 1 double dash, which is at this location as well. So here we have A double dash. Then for B and H, plotting a light horizontal line. Point B, as I have explained, it is on generator O to 2, and H is on O to 8. So measuring the same radius and marking on O to 2, O double dash 2 double dash and O double dash 8 double dash. So here we have B double dash and H double dash. Next, for C and G, plotting it light up to the slant edge, measuring the distance from the point O dash up to this, and point C is on O to 3, G is on O to 7. So taking this radius, marking it on O to O double dash 3 double dash, O double dash 7 double dash. So this will give us C double dash and G double dash. Now after I have located C double dash, G double dash, the next points are D and E, which we are seeing in the top view. That same points are there at the base in the front view. So I'll call them as D dash and E dash. Now for location of these 2 points D dash and E dash, as we see in the top view, point D is in between the divisions 3 and 4. So here in between 3 double dash and 4 double dash there will be point D, and for it I will take the distance from the division 3 to point D and mark it from 3 towards 4. So taking this distance and marking it on 3 towards 4. So this point is D double dash. Next, for point E, in a similar manner, I'll take the distance from point 7 up to point E. They are at the same location, and mark it on 7 towards 6. So marking it from 7 towards 6. That will give me the point E double dash. Next, I will have to join all these points in proper sequence so that we get the development. And here we have A double dash, B double dash, C double dash. It will be connected to D double dash, and similarly onto the other side. Let us get started. So here I'll be connecting points A, B and C together with the help of a light curve. Similarly A, H and G also with the help of a light curve. Then C double dash will be connected to D double dash as C and D are connected. C double dash to D double dash connected. Similarly, G double dash will be connected to E double dash because G and E are connected. Now, I'll make these curves dark. So C double dash to D double dash will be connected. Similarly, onto the other side. Now, after joining these points, the next thing is we have to make it dark, the remaining part, and for that here if we look, then D, 4, 5 and 6, this part has been removed, which is there onto the right hand side. So 4 double dash, 5 double dash, 6 double dash, this won't be dark, but the remaining part, which is 1, 8, 7 and E, this portion will be dark. Next 1, 2, 3 and D, that is 1 double dash, 2 double dash, 3 and D double dash, they will be made dark. So here I'll show the procedure. Next, after making this dark, here we have A dash to 1 dash, they are connected, so there should be dark line from A double dash to 1 double dash, and another dark line from A double dash to 1 double dash here. So this is the development. Here apex has been removed, so this portion should be light, only this much part is visible. So that is the development of lateral surface for the cut cone which is given to us. Next, after completing this, here I'll give the dimensions. The diameter of the cone is given, it was 70 mm, and the height was 90 mm. 90 mm. Next, here we have XY line, and this is VPHP. The distance of the cutting plane from the edge, this distance is given, that is 15 mm, and with this we complete the problem.